Welcome. In this episode, we're going to talk about malware analysis. It involves not only acquiring technical skills, but also diving into the complex and often hidden aspects of digital threats. For a cyber threat analyst, the first step is to learn the types of malware that are designed with specific malicious intent. In order to understand how to counter it, it is worth analyzing the techniques and tactics it utilizes. Viruses are programs that are designed to cause damage to computers and networks. They can spread independently and modify other programs or files, hiding from the user. Viruses can delete or modify files, interfere with system operations, steal confidential information, or use computer resources to attack other computers. There are also programs called worms. This is autonomous software that multiplies in networks and devices, sending copies of itself. They use vulnerabilities in operating systems or programs, contact lists to send out emails, and instant messages. The worms can cause significant damage, including overloading a network, deleting or modifying files, stealing confidential information, or even destroying data on infected computers. Trojans deceive users by hiding under the guise of legitimate software. They hide their malicious functionality behind the facade of normal operation. In recent years, the number of ransomware attacks that encrypt the victim's data and demand a ransom for unlocking it has increased dramatically. These attacks target everyone from individual users to large corporations and government agencies. Cryptojacking has become a significant threat. In this case, ransomware uses the victim's computing resources to mine cryptocurrency and often goes undetected for a long period of time. Advanced Persistent Threats (APTs), which are sustained and targeted cyber attacks, use a combination of different types of malware to penetrate a targeted environment and remain undetected for a long time. These threats often involve sophisticated reconnaissance and lateral movement tactics, making them much more difficult to detect and destroy. Also, the delivery mechanisms of malware are becoming more and more sophisticated. In phishing attacks, which were once easy to identify, attackers now use highly persuasive social engineering tactics to trick users into installing their software. Supply chain attacks have increased in numbers as well. A supply chain attack is a cyber attack that seeks to damage an organization by targeting less secure elements in the supply chain. The attacker compromises one or more components of the development or delivery process. Such an attack could use counterfeit chips that are being used in the production of a computer or medical device. Or the attack could inject compromised code into a software tool. There are a number of different scenarios and methods, but the key is that this attack uses reliable channels to penetrate and achieve its goals. Studies show a significant increase in suspicious traffic during major geopolitical events. State-sponsored hackers and politically motivated cyber campaigns use malware as a tool of espionage, sabotage, and influence. The biggest threat to which Ukraine's cyber defenders responded in 2023 was attacks by Russian Gamma-Redon group. They were aimed mainly at Ukraine defense entities, diplomacy, and internal security. Gamma-Redon and the parts of their attack chain are constantly appearing in the main threat alerts sent to our Ukrainian partners. On the screen you can see 5 behavioral patterns that demonstrate the consistent use of lol bins and related techniques, such as executing a W script, Windows script host. This is a simulation of a legitimate Windows process, which is likely used to mask the development of malware under the guise of expected activity. Typically, financially motivated cyber criminals are involved in cryptocurrency mining and information theft, but they also continue to attack Ukrainian organizations in many industries, which indicates a wide range of threats to Ukraine. These two schemes illustrate Gamma Redden's continued activity and highlight the variety of threats in Ukraine. These include downloaders, information stealers, ransomware, cryptocurrency miners, and Raspberry Robin, a family of malware that remains a constant threat to corporate environments. Or, for example, SmokeLoader, which is a downloader used by various groups. SmokeLoader is usually sent via email and downloads malware to infect computers. The knowledge gained from such cyber attacks can be used to strengthen information security strategies. This includes identifying potential vulnerabilities in critical infrastructure systems, developing more reliable detection and response mechanisms, and creating contingency plans for such incidents. Detailed information about attacks, including the tools used, vulnerabilities, and operational tactics, should be analyzed. This data should then be placed in a geopolitical context to understand motives and future goals. Not only technical analysis is important, but also the political landscape and motives for attacking specific types of infrastructure. Cooperation with international communities, exchange of views, and experience are important in creating a collective defense against complex threats. When you start studying malware, both static and dynamic analysis are useful. Static analysis involves studying the structure of the malware, examining the code and behavioral patterns, but without actually executing the programs. It is similar to studying the structure of a car before you start it. You analyze the binary code, looking for inline strings, suspicious API (application programming interface) calls, and other indicators that point to malicious intent. The tools used in static analysis can range from simple hex editors to more sophisticated disassemblers. The aim is to gather as much information as possible from the malware without revealing your presence. For example, you can track the activity of a malicious application, analyze data transfers, etc. Dynamic analysis complements static analysis. It allows you to observe the interaction of malware with the system in real time in a controlled, isolated environment, often a virtual machine. This way you can track its behavior, network traffic, file interaction, and changes in system processes. Dynamic analysis helps you understand the real impact of the malware, its communication strategies, and distribution methods. Although both static and dynamic analysis have their strengths, the most effective way to use them is in tandem. For example, static analysis can detect a code snippet designed to connect to a remote server. But only dynamic analysis can show you if and how that connection is being established and used. It's important to set up a secure environment where you can analyze malware without risking your network or data. This involves creating isolated systems, often using virtual machines, that can be easily restored to their previous state if malware causes damage. It goes without saying that before doing so, you should always make a backup or snapshot of the system state to which you want to return. For effective and secure analysis, it is crucial to understand how to properly set up your analysis environment, including isolating it from the internet while simulating an online connection. Documenting your findings and maintaining a repository of analyzed malware samples can be an invaluable resource for future analysis. Over time, you'll begin to recognize patterns and techniques that attackers often use, which will increase your ability to analyze new threats quickly and effectively. As you go deeper into the analysis, you will encounter more advanced and complex threats. This stage involves reverse engineering complex malware. It is a process similar to solving a puzzle, penetrating layers of encryption and masking to reveal the true intentions and mechanisms of the malware. Behavioral analysis and heuristic methods are becoming increasingly important here, allowing you to identify and classify malware based on its actions rather than static characteristics. The tools you use are just as important as your skills. Network analyzers are important for understanding the network behavior of malware and its data transmission methods. By monitoring network traffic, these tools can help you detect suspicious patterns, data leakage attempts, and identify command and control (C2) server communications. They also allow you to intercept and analyze data packets sent and received by malware. thus providing insight into its target behavior and goals. For example, these are Wireshark and TCP/DOM, which we discussed in the previous episode. Debuggers and deassemblers help you examine the code of an access control device at the assembly level and get a detailed understanding of its functionality. These tools allow you to follow malware step by step and see how it interacts with system processes, modifies files, and behaves under various conditions. Such a detailed view is important for understanding the mechanisms of malware and identifying potential vulnerabilities or kill switches. These are IDA, Ghidra, AliDBG, Radari2, and Binary Ninja. A sandbox environment is an isolated environment for securely analyzing malware. It allows you to observe the behavior of malware without risking the real system. They simulate different operating systems and network configurations, allowing you to verify how malware behaves under different conditions. Popular hyperversions are VMware, VirtualBox, Proxmox. Automated malware analysis platforms can help you deal with the large number and variety of malware. They use different algorithms and heuristics to quickly analyze and classify malware samples, provide initial assessments, and allow analysts to focus on more complex tasks. However, while automation is a powerful tool, it is important to supplement these findings with manual analysis to gain a deeper understanding and verify the results. The most popular are VirusTotal, AnyRun, Malware Bazaar, and Cisco Malware Analytics. Threat intelligence platforms provide information about known ransomware samples and attack patterns and threat actor profiles, that means context. By comparing your analysis results with the collective data, you can identify similarities with known threats, understand the broader implication of your findings, and stay up to date with the latest development in malware. Some of these platforms include Meter ATT and CK, VirusTotal, Malware Bazaar, Feodo Tracker, SSL Blacklist, URL House, ThreatFox, and Yara IFY. Often due to a unique nature of malware samples, you should additionally develop your own special scripts or tools. This typically involves writing scripts to automate a particular aspect of the analysis or developing a tool to decrypt a special encryption algorithms that malware uses. Developing such customized solutions will not only help you with your ongoing analysis, but will also improve your overall problem-solving skills and understanding of malware behavior. The right tools combined with the analytical skills will enable you to unravel even the most complex malware and provide cyber defenders with critical information.